Hello my dear students, welcome to IMS Gate Academy. Hi, I am Vipin Mishra, the lead mentor at IMS Gate Academy, and I welcome you all on the Gate Score Booster series of IMS Gate Academy. So I hope that you all are preparing well for the GATE exam, and in the meanwhile you are also enjoying the GATE Score Booster series of IMS Gate Academy. So today we are going to discuss the second session on power system. We have already discussed so many questions in the first session of power system. So let me start the second session. Okay, so these are the topics, or we can say the chapters, that we have to discuss in the subject power system. So in first session we have almost completed the compensation technique and load flow analysis, and today we'll be discussing the rest of the subjects. Prakhar is saying audible very low. The voice is very low. Is it with everyone audible? Okay. So today we will discuss the rest of the chapters. Okay. So let's get started with insulators, cables and distribution today. Okay. So this is the first question that I am having. So what has been said in this question is a string of 7 suspension insulator is to be fitted with guarding ring. If the pin to earth capacitance are equal to C, then the value of line to pin capacitance C3, that would give uniform voltage will be what? And these are the options among which you have to choose. Okay. So in order to get the uniform voltage distribution, guard ring is used, and what you have to do, you have to find the value of this capacitance C3. Okay. So let me see whether you can solve this question or not. So let me give you some time, okay, and you can apply your knowledge, what you know about this topic, and then we will discuss the solution of this question. So your time starts now. You have to find the value of C3. Okay. So there is only one formula. Prakhar is getting an option C. Very good, Prakhar. So what about others? What is your answer? So Prakhar has answered that C will be the correct option. What about the others? Are you getting the same answer as well, guys? You only have to know one equation and you will be able to solve this question very easily. Okay. Last 10 seconds and I'm only having one answer. Okay. So let's see how to solve this question. If suppose we are using the guard ring, okay, then capacitance of the pth metal link, we have a formula related to that. The capacitance to pth metal link, the capacitance of pth metal link Cp, this is equals to PCP upon N minus P, PCM upon N minus P. Okay. What is P? P is the metal link number. Okay. P is the metal link number and we have to count it from the top. So if you are counting from the top, okay, you have to count in this order 1, 2, 3. So C3 we have to find. So metal link number will be 3. Okay. So we will be writing here C3. The metal link number will be 3. Cm is pin to earth capacitance, which is given here C. So you will write here C. N is total number of discs. So how many discs we are having? 1, 2, 3, 4, 5, 6 and 7. Okay. So 7 discs we are having, minus P again is 3. So what you will be getting? You will be getting 3C by 4. That will be the value of C3. So this is the very important formula. If you have the formula with you, you will be able to get this answer. Okay. So our answer is C3 equals to 3C by 4, which Prakhar has answered. Current balance. Yes, very good, Prakhar. Okay, this is the concept required. Very good. So this is going to be the correct answer for this question. Okay, and this is how you have to solve this particular question. Wow, sir, this formula I was not knowing. Very good. Okay, so this is the purpose of GATE Score Booster series, to make you approachable towards all the formulas and concepts. Okay, so that you can see, you can manage the unseen questions. Okay, now let me move towards the next question. So the next question is this one. Let me read it out. A three-phase transmission line is being supported by 3 disc insulators. Okay, the voltage across the lowest insulator is 13.1 kV and that across the next unit is 11 kV. Then what will be the voltage between the lines? So there are 3 insulator discs. The voltages across the lower 2 discs is known to us, and we have to calculate what voltage the lines are carrying. Okay, so your time starts now. This is what we have to calculate here, and your time starts now, and you can solve this question as well. So in GATE exam you have almost 3 minutes to solve any question, but I am giving you 2 minutes here, so you can save your time in most of the questions, and you can apply this time in questions which are a little bit tricky. Okay, so we have 3 discs and the voltage across the lower disc and the second disc is known to us. Okay, then we have to find out what voltage the lines are carrying. Everything is fine with the voice right now, Prakhar? Am I clearly audible to you? So last 25 minutes. Come on guys, you can solve this question. Last 10 seconds. Prakhar is saying last unit voltage will be V1 1 plus 3m plus m square. Okay, let's see how to solve this question. So what has been given to us is we have 3 units, isn't it? 3 discs are there like this. Okay, and the lower one is carrying the conductor. Okay, so this will be the pin to earth capacitance. Fine, this capacitance will be C, C and C, and these capacitance will be C of M. Now what is this voltage? You can make one more capacitance here if you wish. So this voltage is, let me call this voltage to be V3. Okay, and this voltage is given to us. The voltage across the lowest insulator is 13.1. This is 13.1 kV. Okay, and that across the next unit, the unit next to it, the voltage across it, let me call this V2, and this is given to us, which is equals to 11 kV. Okay, then the voltage here we can assume that this is V1, and we don't know the value of V1. Okay, we don't know the value of V1. What is the value of V1? We don't know. So now what we have to do here? We have to calculate what voltage this line are carrying. Okay, so the voltage between the lines you have to calculate. Fine. Prakhar is saying 11 and 13.1. Okay, let me see. So just see guys, what has been given to us. You know that the value of K. Okay, the value of K is Cm upon C. Fine. So we define K to be Cm upon C. So we have to find the value of K first of all. So you know that in terms of K, V2 is basically equals to V1 1 plus K, or K plus 1 we can write. Okay, so from here what will be the value of V1? It will be V2 over 1 plus K. What is given as V2? 11 upon 1 plus K. Let me call this equation number 1. Similarly, if we apply V3, which is V1 K square plus 3K plus 1. So from here what will be the value of V1? It will be V3 upon K square plus 3K plus 1. Now what is V3? V3 is given 13.1 divided by K square plus 3K plus 1. Okay, let me call this to be equation number 1. Now when you will solve these two equations, okay, the variable is only K, the unknown is only K. So when you will solve this for value for K, the acceptable value of K that you will be getting will be 0.1. Okay, so from 1 and 2 you will get 0.1. Voice is very low. Still the voice is very low. Prakhar, Nikhil, the voice is very low. You are not able to listen me properly. So from here the K value that you will be getting is 0.1. Okay, so if you got the value of K, okay, then what we have to find? We have to find the voltage of the line. So voltage of the line will be V. Okay, V equals to V1 plus V2 plus V3. Fine. Now we know the value of V2 and V3, but we don't know the value of V1. So can we find the value of V1? Okay, so from this equation, equation number 1. So if I try to find the value of V1, which is V2 upon 1 plus K. So V2 is basically what? 11 upon 1 plus 0.1. Okay, so how much you will get? Around 10 kV you will get. So this will be the value of V1, isn't it? Yes. So we will put here the values of V1, V2 and V3, 10, 11 and 13.1. So how much it will become? The value of total voltage that you will be getting is around 34.1 kV. Okay. Now whatever voltages we have used till now are the phase voltages. Okay. But what has been asked to us is the voltage between the lines. Okay. Voltage between the lines. If suppose this is not asked as well, then if you have to find out what voltage the lines are carrying, it should always be in terms of line values. Okay, because in three phase the voltage mentioned is always line voltage unless specified. But from the calculation whatever you are getting is a phase voltage. So you need to convert that voltage into the line voltage. So this voltage will be the phase voltage. Okay. Now what will be the line voltage? So you have to multiply this with √3. Now when you will multiply, what you will be getting? 59 kV is the answer. Okay, 59 kV will be the answer. So never ever forget this particular thing. This is very, very important. Whatever calculations we are doing here are in terms of phase voltages, and answer that you have to give is in terms of line voltage. Okay, if you will be able to remember this particular thing, you will certainly going to score marks from this topic. Okay, so any problem anybody is having? Is this clear to everyone? I hope it is. Okay, very good. So let me move towards the next question. These kinds of question you can expect in the upcoming GATE exam. Okay. Now see this question. Now what do we have here? The capacitance of 3-core lead sheathed belted cable are measured and found to be as follows. Okay. So this is the 3-core belted cable that we have. Now following tests are being done. Between one conductor and other two connected together to sheath, the capacitance found to be 5.2 microfarad. Then between 3 core bunched together and the sheath, the capacitance was found to be 7 microfarad. The charging kVAR when the cable is connected to an 11 kV 50 Hz 3-phase supply will be what? Okay. So you have to calculate under these tests, if they are performed, what will be the charging kVAR. So you have to find the value of capacitance per phase. Then you will be able to calculate what will be the kVAR. Okay, the charging kVAR. So let me give you time for this question, and I am giving you more time for this question. Okay, this is a lengthy type of question, but be prepared. It is an easy one. You can surely get marks in this question. Okay, and it is manageable. So take your time, guys, and I need a correct answer for this question. So we have last 40 seconds left, guys. I hope you are able to solve this question as well. We have 3-core belted cable and you have to apply these two conditions to calculate the capacitance per phase. Okay. Now, if you will be able to get that, then you have to calculate charging kVAR. So, Prakhar is getting an answer 395 kVAR. Okay, let us check. Last 10 seconds. Any other answer? Okay. So, just see. Sorry. C1 is the capacitance between the conductors. Okay. And C2 is the capacitance between the conductor and the sheath. Now, if this delta is converted into star, what you will be getting? And I hope that you all know about this. If suppose this delta will be converting into star, we will be getting this combination, isn't it? Now, what will be the capacitance when it is converted into star? It will be 3C1. Okay. So this will be the neutral point, okay, and we have this capacitance as well. The situation will change like this. This is the sheath, we can connect, we can take it as a ground, and this is the R conductor, and between R conductor and the neutral or ground again we are having the C conductor, okay, like this, 3C1. So if I ask you what will be the C phase, means between R and the ground or neutral, what will be the equivalent capacitance, which is called as the phase capacitance. So it will be 3C1 plus C2, okay, it will be 3C1 plus C2. So capacitance per phase is basically 3C1 plus C2. Now you have to find out the value of C1 and C2, okay. You need to find out the value of C1 and C2. The voice is low, but I think it is manageable. All others are able to listen me, okay. Just focus, you will be able to listen me as well, okay. So we need to find the value of C phase, and C phase is basically 3C1 plus C2. So we need to find the value of C1 and C2, okay. Now what we are doing in the first test, between one conductor and other two conductors connected together to sheath. So if we will be doing this exercise, what we will be getting, just see. So two conductors are connected together and they are connected to the sheath. So this is what we are doing, okay. So equivalent combinations for this case will look like this. We will be having one capacitance between the ground, which we can call it C2, okay, between sheath and this R phase. Let me call this to be R phase, and from R phase to sheath we are having two more capacitances like this, okay. These are C1 and C1. So these two capacitances and this capacitance will be there, okay. Now if I call this combination to be CA, equivalent combination to be CA, so CA will be what? CA will be 2C1 plus C2 here, isn't it? It will be 2C1 plus C2 here. Now in the next case what we are doing is, in the next case, between three core bunched together and the sheath. So we are bunching the three cores together, means we are doing something like this. These three cores, they are bunched together. So when you will bunch them together, the combination will appear to be like this. All R point, Y point and B point, they are bunched together. So you are only having the capacitance to the sheath only, okay. So C2 and C2, only three C2s will be there like this, okay. Now if I call this combined combination to be CB, then what will be the combination? CB, if the combined combination is called to be CB, then CB will be basically 3 times C2, isn't it? Or we can call C2 to be CB by 3. Now this combination CB is given in the problem. It is 7 microfarad. So when you will put here 7 by 3 is what you will get, okay. 7 by 3 is what you will get. Now how much is 7 by 3? So 7 by 3 will give you 2.33 microfarad. 2.33 microfarad. So this is how you will find out the value of C2. Now come back here and just see. When we are doing this test, the equivalent capacitance value is given to us 5.2. It is given 5.2. Now this is equals to 2 times C1 plus C2. Now we have calculated is around 2.33. So from here we will find the value of C1. How much will be the value of C1? So C1 that you will be getting from here, what answer I am having is 1.43 microfarad. I hope you are also getting the same. 1.43 microfarad. So just see, by conducting these two tests, we have calculated the value of C1 and C2. Now, if you will see, if C1 and C2 are known to us, okay, so if we have calculated C1 and C2, then what will be the C phase? C phase will be 3C1 plus C2. So just put the value 3. C1 is 1.43. And what is C2? C2 is 2.33. So what value of C phase you will be getting? C phase value you will be getting equal to 6.62 microfarad. Okay, 6.62 microfarad. This will be the value of C phase. So up till this step, Prakhar, are you also getting the same answer? Okay. Now what we have to calculate is charging kVAR. Okay. So kVAR means QC, reactive power. It will be what? It will be 3 V phase square divided by XC, isn't it? 3 V phase square upon XC. Or what you can write is it to be 3 V phase square XC is 1 by omega C or 1 upon 2 pi FC. That will come into the numerator itself and it will become 2 pi F into C phase. So ultimately the formula will become C 6 V phase square pi F into C phase. Okay. So come back and calculate the value right now. 6 into what is the V phase voltage? So voltage is given to us 11 kV. Okay. Now in 3 phase, the voltage given is always a line value. So you need to convert it into phase value. So it will be 11 by root 3, 11 kV, okay, by root 3 square into 3.14 into 50. And what do we have as the value of capacitance? 6.62 microfarad, means 10 to the power minus 6. Now after solving this, what answer you are getting, guys? Aryan is saying 251.9. Prakhar is saying 304. Okay, so let me calculate. With this given data, what could be the possible answer? So we have 6 into 11 square 121 divided by 9 multiplied by 3.14 multiplied by 50 multiplied by 6.62. So 83.84. I think somebody has given this answer before. I am getting an answer of 83.84. Aryan, earlier you got the same answer. Why you guys are getting 304 and 251.9? My answer is 83.84. 6 into 11 square 121 divided by root 3 square, which is 9, multiplied by 3.14 into 50 into 6.62, and answer will be 83.84. I think Aryan, you were getting same answer earlier. 251 point something, both of you are getting. So why is this difference between your and my answer? Which value you are getting different from me? Can you just state that particular thing? Which value you are getting different from me? Prakhar and Aryan, just let me know why you are getting a different answer. I think Aryan, earlier you are getting 83.84. Root 3 square is 3. Yes, very good. Okay. And that I have written 9. Okay. So when I will multiply my answer with 3, yes, I will get 251.3. Yes, that's the correct answer. Very good. 251.3 kVAR. Okay. So just see. This is how calculation mistakes can be avoided. Okay. So root 3 square will be 3, not 9. Okay. So what answer I am getting? If you multiply just 3 with that, you will be getting the same answer. So both of you have answered correctly. Okay. Very good. So I hope this is clear to you. Now be prepared for these kind of questions. Okay. Because these questions are very important, and a long back they were the part of GATE exam. Since then there were no question from this particular topic. So this year you may get a question from this particular topic. Okay. So now let me move towards the next question. So this is my next question, and this is a very good question. Okay. Related to the distribution system. Now what has been said here in this question is, an electric train taking off constant current of 600 ampere moves on a section of line between two substations 8 km apart, maintained at 575 volt and 590 volt respectively. The track resistance is 0.04 ohms per kilometer. Both goes and returns. The point of minimum potential along the track is at a distance from 575 volt substation will be. You have to find out the point of minimum potential. So can you let me know whether it is line fed from one end or whether it is the case of line fed from both ends? Can you guys answer me that question? And if you know that, then I know that you will be able to solve this question as well. Okay, I know that you will be able to solve this question as well, and I am giving you 3 minutes because calculations are so much here. So whether it is a case of line fed from one end or line fed from both ends, and then you have to find out the minimum potential point. Okay, both ends, very good. Line fed from both ends, and you have to find out the minimum potential point. Okay, and this is the situation in which you are in. So the track, which is 8 kilometer long, at one end it is fed from how much voltage? 575 volt. At the other end it is fed from 590 volt. Okay, and train is moving somewhere here. Let me call this distance to be x, and if this distance is x, this distance will be how much? 8 minus x. So the train is at x kilometer from 575 volt line, and it is drawing 600 amperes. Okay, so this is what is given to us. Now I hope that you can solve this question. Okay, let me call this point to be A point, this point to be B point, and this point to be P point. So what you have to find? You have to find the Vp voltage. You have to find out the Vp voltage. Okay, if we assume that the current here is I of A, then the current here will be what? I of A minus 600 in this direction, or in this direction it will be 600 minus of IA, whatever you can take. So time is about to over, your 3 minutes are over, and I am not getting any answer. So are you very close to solve this question? Any answer from anybody? Okay, let's just see. So guys, what has been given to us is, just see here, we have been given that the track resistance is 0.04 ohm. Okay, so what will be the resistance of this part? RAP, resistance of this AP part. So it has a length of x kilometer, and per kilometer resistance is 0.04. So it will be having 0.04 x ohms resistance, isn't it? Similarly, what will be the resistance of our BP part? It has a length of 8 minus x. So per kilometer resistance is this much, and the length is 8 minus x. When you will multiply, you will get resistance in ohms. So these will be the resistance of the tracks. Now if I find out the value of Vp, I can find it in two ways. Vp, if I am taking this end, so from this end it will be equals to what? It will be equals to the voltage at A, which is 575 minus the drop in this particular part. Okay, so the current is IA and the resistance of this particular part, which is RAP, is around 0.04x. Okay, if I find from this way, it will be the resistance. Very good, Prakhar. Now if I find from this end, so what I will be writing if I am calculating this from this end? So it will be voltage at B, which is 590 minus drop here. So drop here will be current is 600 minus IA. Okay, and the resistance of this part is 0.04 into 8 minus x, isn't it? So you will get this equation if you will write the potential Vp from both ends, isn't it? Because from both ends, if you are trying to write it, it should come same. So if we write this equation, there is only two unknowns are here, IA and x. So if I write for IA, what will be IA from here? We will get one equation IA, which is 177 minus 24 x upon 0.32. Okay, we will get this equation in terms of IA. Now if I put this value of IA in any of this equation, okay, let me put it in Vp. So what will be Vp value? So I will be writing here 575 minus IA value. If I write this IA value, which is 177 minus 24x upon 0.32 into 0.04x. So this will be my Vp voltage. Okay, but what I have to calculate? I have to calculate the point of minimum potential. Okay, so this Vp has to be minimum, isn't it? You are getting this equation. Okay, now when you will adjust it, you will get this kind of equation. It will be 575 minus 22.01x plus 3x square. You will get something like this in terms of Vp. Now we are talking about minimum Vp. Okay, point of minimum potential. So guys, if you are having an equation and you have to find out the minimum or maximum value, what is the first thing that you will be doing? You will be derivating it with respect to the variable and you will be equating to 0, isn't it? So for minimum Vp, what you will do? You will differentiate it with respect to x and you will equate it to 0. And the moment you will do it, you will get the value of x. Okay, so the moment you will do it, you will get the value of x, which is coming out to be 3.67 kilometer. Okay, so this equation you will get in terms of Vp, and whenever we have been asked about minimum and maximum value, we have to derivate with respect to the variable and equate to 0 to get the condition. Now when you will put the value, if suppose you are putting this value here in this equation, you will get the minimum value of potential as well. Okay, so minimum value of potential, where it is occurring? It is occurring 3.6 kilometer apart from point number A. Okay, and what we have to calculate here? The point of minimum potential along the track at a distance from 575 volt. So how much distance it is? 3.67 kilometers. So from 575 volt line at a distance 3.67 kilometer, we will get a minimum potential point. Okay, if suppose we have to calculate the value of minimum potential, you have to put this x in this equation and you will get the minimum value of Vp. Okay, so which option is correct? Option number B is correct. So this is how you can solve this kind of question. So this is how indirectly distribution question has been asked. Okay, now be ready to solve these kind of question. Now they will change the language, they may change the situation, but still you have to do the same analysis. So is this clear to everyone? Prakhar, Polly, Aryan, is this clear to everyone? Nikhil, any doubt that you guys are having? Is it clear to everyone? Just give me a reply. Any doubt anybody is having? Very good. And this is a very, very good question. Okay, a question from insulator cable and distribution. Okay, it has been asked way back in the GATE exam. So be prepared that this time you may expect a question from insulators, cables and distribution. And if there will be a question, these are the topics from where you can expect a question in the GATE exam. Okay. So let me move towards the next question. I hope it is clear to everyone. Yes. So I hope that you are liking the questions and you are liking the way I am delivering it. So guys, if you are really liking it, you can join our Telegram channel. The link is given in the description box. You can click on it and you can join our Telegram channel. Okay. If you will join our Telegram channel, you will be getting the links of every YouTube class that we are going to take. Whatever we are teaching here, the notes will be provided to you after the class, and you will be getting information about necessary seminar and webinars, the job notifications, okay, and daily practice quizzes as well. So join the Telegram channel. So insulators, cable and distribution. This is done. Now let me move towards the very, very important topic from power system, which is the fault analysis. Okay. So what are the important topics? Symmetrical fault analysis, unsymmetrical fault analysis, bus impedance matrix. Questions related to bus impedance matrix. Not the formation of it, but the questions related to the fault analysis using the bus impedance matrix. Okay. We have two kinds of matrices in the power system. Y bus or bus admittance matrix, which is used to just get the information about load flow analysis. Okay. And we have another matrix in power system which is called as Z bus matrix, which is used for fault analysis. Okay. So let me move towards the first question from this chapter. So this is the first question that I'm having. Okay. Let me read it out. A generator with zero resistance having 1 per unit voltage behind transient reactance is subjected to different types of faults. The type of fault and resulting fault current is mentioned in the following table. So when we have 3-phase fault, the fault current is 3.33 per unit. Double line and LG fault, respective fault currents are given. We have to calculate the value of positive, negative and zero sequence impedances. Okay, what will be the possible values of these impedances? This is what you have to calculate, and this is very easy, and this is the most probable question for the upcoming GATE exam. Okay, and I hope that you people are able to solve this question. In this way you can check your preparation level of power system as well. Okay, and your time starts now. Let me see who can solve this question. Very good, Aryan. You got the answer. Aryan is saying A is the correct answer. Everybody else is getting A as answer. So the time is over. Okay, and only answer that I am getting is from Aryan. So let's see how we can solve this question. So we have been given the fault current. So this is going to be the fault current for three-phase fault. This is going to be the fault current for double L fault, and this is going to be the fault current for LG fault. Okay. So let me take the example of LG fault first. So if suppose I have to write LG fault, okay, what is the formula of LG fault? It is 3E over x1 plus x2 plus x0, positive, negative and zero sequence impedance, and there is no fault impedance unless we could have written here plus 3ZF. Okay. So what has been given here is 3.33 per unit. Sorry, 3.01 per unit, and you have here 3 per unit voltage is given 1 divided by x1 plus x2 plus x0. So from here what will be x1 plus x2 plus x0 will be equals to 3 upon 3.01. Okay, how much we will be getting here? 3 upon 3.01. Okay, so how much is 3.01? Let me just solve it. Almost 1 we will be getting. .99. Okay, we will be getting 0.99 here. Now let me apply the other formula. After that, if we apply the formula for the three-phase fault, so what will be the three-phase fault formula? So formula for three-phase fault is, it is equals to E upon simply x of 1 only, isn't it? E upon x1, and this fault current is given to us. How much is it? It is given equal to 3.33. So if we just put the value, pre for voltage is 1, so you will get the value of x1 from here, and it will be 1 upon 3.33. So how much is 1 upon 3.33? It will be 0.3 per unit. Okay, so just see, first answer is here, x1 value will be 0.3 per unit. Now if we apply the second formula, last formula for LL fault. Okay, so for LL fault, what is the formula? Root 3E upon x1 plus x2. Okay, there will not be any x0 here because there is no ground return. Now what is the value given here? 2.23. Root 3 into E will be 1 upon x1 plus x2. So from here x1 plus x2, it will be root 3 upon 2.23. Now how much will be x1 plus x2? 0.77. Okay, and x2 we have to calculate because x1 we have already calculated. So 0.77 minus of x1 minus of 0.3, so you will get 0.47. So you cracked two values, x1 and x2. Now if you will come back in this equation, so from here what will be x0? It will be 0.99 minus of x1. How much is x1? 0.3. x2, how much is x2? 0.47. So when you will do this, you will get the value of x0 equals to 0.22. Okay, per unit. So just see, in order to solve this equation, you only require to have the formulas of different fault. Okay, which you definitely must have practiced. So what is difficult in this question? These formulas you must have practiced. Now you have to apply these formulas and you have to get the value of x1, x2 and x0. So 0.3, 0.47 and 0.22. So just see, 0.3, 0.47 and 0.22, which is given in option A, and RN, your answer is absolutely correct. Okay, so this is how, in this way, by solving this question, we have practiced all the formulas related to the fault current. Okay, and somehow you will definitely get a problem in the GATE exam related to these fault currents. Okay, so this is how we have solved this particular question. You got to know about the formulas. Okay, you got to practice about the formulas of fault current, which is very, very important for us. Now if you are able to solve this question, you can solve this one as well. So what is given here is, the 6600 volt 10 MVA 3-phase alternators are connected to a common set of bus. Okay, so these alternators are connected to a common bus. Each has a reactance to positive sequence current of 15%. Okay, positive sequence reactance is 15%. The reactance to negative and zero sequence currents are 75% and 30% of the positive sequence value. Okay. An earth fault means line to ground fault occurs on one bus bar. There are three such alternators connected in parallel. Okay, so whatever is given for one, there are three such alternators connected in parallel. If only one of the alternator neutral is solidly grounded, rest two are having no neutral. Okay, and the others are isolated, then the magnitude of the fault current will be, you have to calculate the magnitude of fault current. Okay, what fault we are having? Line to ground fault, and there are three generators connected in parallel to a common bus like this. Only one generator is having its neutral grounded, rest are having no neutral. Okay, so this is the situation in which you are in, and you have to calculate the line to ground fault current. I know that it will take time, so I am giving you 3 minutes for this question, but you can be able to solve this, I am very sure. Okay, take your time guys, but I want a correct answer from you. Okay, now from fault analysis they can't give you a question more fragmented from this other than this question, isn't it? Everything possible through which the gate authorities can modify a question from fault analysis is present here in this question. Okay, if you are able to solve this one, I'm sure you will be able to solve any question related to fault analysis. I know that, but others are managing. Can you manage as well? Open the session on the laptop. I think then it will be very good. Okay. We have verified and there is not at all any problem. Okay, maybe due to some other reason you are getting very low voice. So last 1 minute is what we are having, and guys, I want an answer from you guys. You can solve it, come on. I know that you can solve this problem. Okay, whatever you will be doing is for one generator, and we are having three alternators connected in parallel. Okay, and we are talking about line to ground fault. So in line to ground fault, the three sequence networks are connected in series. If we have three parallel generator, their sequence impedances will be connected in parallel. If you know this one, you will be able to solve this question. Last 10 seconds and still I am waiting for your answers. Okay, so let's just see how to solve this question. Okay, so let me add one page. So first of all, just see what has been given in this question, and before that, calculate the value of I base. So what will be I base? It will be equals to S base upon root 3 into V base. How much is S base? 10 MVA. Okay, divided by root 3, how much is V base? 6600. Okay, so now when you will solve this equation, Rn is getting an answer B. Okay, Let me verify answer. So IB current that you will be getting is 874.79. This will be the IB current. Okay, then if I calculate what will be X base, then it will be equals to V base upon I base. Okay, so 6600 divided by 874.79. When you will do this, you will be getting X base equals to, you will be getting an X base equals to how much? Okay, and just do one exercise here, divide it by √3 as well. Okay, because we are talking about impedances, current impedances, they are always calculated on per phase values. Okay, so from here you will be getting X base equals to 4.35 ohms. Okay, now why we have done this particular exercise, why we have calculated I base and X base? Okay, so it will be very clear to you. Now read the question. It has been given that each has a reactance to positive sequence current of 15%. Okay, so positive sequence reactance in per unit is how much? 15% or 0.15 per unit. If you have to calculate X1 per unit, you must have calculated X1 actual in ohms divided by X base. This is equals to 0.15. So can you tell me what will be X1 value in ohms? It will be 0.15 into X base. Okay. Now when you will put the value of X base, which you have already calculated, you will get X1 equals to 0.65 ohms. Just see. So this is how we have calculated X1. So X1 in terms of ohms, what it will be, we require the value of X base, and this is why we have done this analysis. Okay, so now we are having the value of X1 with us. Okay, so X1 is with us right now, and let me erase it. Now X1 is with us. Now what will be the value of negative and zero sequence currents, impedances? So negative impedance, okay, in ohms, it is 75% of positive sequence reactance. So it will be 0.75 of X1. Okay. So 0.75 of X1 is how much? 0.65. Okay. So what you will be getting as the value of X2? X2 will be around 0.49 ohms. Okay. Similarly, what will be the value of X0, zero sequence impedance in ohm? It is 30% of positive sequence. 30% means 0.3 of X1. So you will write here 0.3 into X1 is 0.65. So 30% of it will be how much? 0.19. Okay. So just see. Half the question is almost done. You have the values of X1, X2 and X0 right now with you. Okay. This is how you can calculate the value of X1, X2 and X0. So let me write all these values. So what value we are having for X1? X1 is 0.65 ohms. X2 and X0. X0 is 0.19 and X2 is around 0.49 ohms. Is that correct? Yes. So right now we are having these values. Now what has been given to us is that alternators, they are connected in parallel to a common bus bar like this. Okay. And this alternator, it has its neutral grounded G1. G2 and G3, their neutral are not grounded. And there is a line to ground fault occurring on the bus bar. Okay, then you have to calculate what will be the value of line to ground fault current. Okay, you have to calculate what will be the value of line to ground fault current. If I ask you one simple question, in case of line to ground fault, how the three sequence networks are connected? They are connected in series. Okay, so you will connect them like this. We have three sequence networks and they will be connected in series like this. So this is positive sequence. Okay, then we have negative sequence and then we have the zero sequence. They are connected in series with respect to each other. Okay, like this. And this is where the fault current will be flowing. Fine guys. Okay, this exercise you will be doing if you have only one such alternator, okay, and whose reactance is grounded to neutral. So this zero sequence component will be represented, otherwise it will be an open circuit. Now if we have three such alternators, then how to draw their sequence network combinedly? So what you will be doing, you will be adding here the other generator, okay, and the third generator as well, like this, okay. Similarly, you will be adding the negative sequence here as well. So because they are connected in parallel, they all will be represented like this, okay. So this is x1, this also will be x1, this also will be x1, this you are writing for g1, this you are writing for g2, this you are writing for g3, okay. Similarly here also x2 and x2. Now what about this? Just see, this will be open circuited, okay, and here also it will be open circuited. So now why this is open, okay, why this is open for g2, why this is open for g3? Because for g2 and g3 there is no ground return available. So if there is no ground return available, zero sequence current cannot flow, and if suppose there is no path to current anywhere, we will represent it like an open circuit, isn't it? This is what we have done, okay. Now if I ask you that what will be the x1 equivalent, okay, so they are connected in parallel, so it will be x1 by 3, so 0.65 divided by 3, this will be your x1 equivalent. And how much you will be getting after doing 0.65 divided by 3? 0.21 something, okay, 0.22 something in ohms. Similarly, from the negative sequence, what will be the equivalent? Negative sequence, they all are connected in parallel, so x2 by 3, 0.49 divided by 3, so what you will be getting? Around 0.17, isn't it? Similarly, if we talk about x not equivalent, zero equivalent, then it will be equal to only this x naught, because they are not the part of the circuit, they are open circuited, so we can't take them. It will only be equals to x naught, which is equals to how much? 0.19 ohm, okay. So all the equivalent positive negative sequence impedances are with you right now. Now if I ask you what will be the fault current, okay, line to ground fault current in per unit, so it will be, formula is 3E upon x1 equivalent plus x2 equivalent plus x naught equivalent. Now put the values, 3 into 1, okay, the values are 0.22, 0.17 and 0.19. So how much you will get as the value of fault current? The fault current value will be, what will be the value of fault current? Let me calculate. So we have 3 divided 0.22 plus 0.17 plus 0.19. Okay, so you will get around 5.17 per unit, okay. But whether we have to give the answer in per unit or in amperes? In amperes. So what will be the answer in amperes? So line to ground current in terms of amperes, it will be equals to 5.17, the per unit value, into the base value. So how much is the base current? The base current we have already calculated, 874.79. So 874.79. So multiply this with 874.79, and what we will be getting? 4524.77. Is that correct? Whether B option is no, we are getting a different answer. Just cross check, guys, whether it is correct. Just cross check whether it is correct. .22 plus 0.17 plus 0.19 is around 0.58. Okay, now 3 divided by 0.58 is 5.17. That is correct. Now when we will multiply it with the base current, okay, so 5.17 into 874.79 sequence reactance is in ohm. Oh my god, this is the problem. Very good, Aryan. This reactance is in ohm. Okay, so if this reactance is in ohms, if this reactance is in ohm, this value will not be in per unit. Okay, and we have to put the value of E not equals to 1. In fact, it will be equals to what? 3 into the way E will be what? 6600 divided by root 3. Okay, and it will be 0.22 plus 0.17 plus 0.19. Okay, so now when you will be doing this, how much you will be getting? Now let me calculate. When we will be doing this particular thing, we will be getting around 19.8 kilo amperes. Okay, so 19.8 kilo amperes, this will be the answer. Okay, directly we are getting in amperes. So 19.8 kilo ampere means 19,818 amperes. So this is very close. So this will be the correct answer. Okay, so just see. Okay, so what we have done? Normally we have a practice of writing these in per units. Okay, and this is what mistakes I have done here. I have taken these values into per unit and I was getting 5.17 and I was writing it into per unit. Okay, which is not in per unit. Okay, so because impedances are calculated in ohms, so we have to calculate this in ohms. So E, you will not be writing it equals to 1. E will be the base voltage 6600 divided by root 3, which is given to us. Okay, because it is current, that is why we have divided by root 3, because currents and impedance, they always be taken into per phase equivalent ones. Okay, this is how you will get this answer. Okay, so I hope this is clear to you. Now this question which we have discussed is a very long one. A lot of concepts have been used here. First of all, if suppose in the question they have given equivalent reactances in percentage of something, how to deal with that, this is what you have learned. Okay, now another thing is, if suppose we are having alternators connected in parallel, then how their sequence networks will be treated. They are also connected in parallel. Okay, second thing. Third thing that we have learned here is, if suppose some alternators neutrals are not present, their zero sequence network will be open circuited. Okay, so these three things you have learned. Now all those the combination of all of them or combination of any two or single one will be asked in the exam. Okay, so the purpose of choosing this problem as in the GATE score booster series is to let you know about all the scenarios that you may be able to see in case of fault analysis. Okay, and one mistake, okay, whether you are putting the values in ohms or in per unit, be very serious about that. Otherwise you have done a lot of hard work but answer will not be matching. Okay, now moving towards the next question. So just let me read it out. A 3-phase 20 MVA 10 kV alternator has internal reactance of 5% and negligible resistance. Okay, internal reactance is 5%. The external reactance per phase to be connected in series with the alternator, okay, to that, so that the steady state current on short circuit does not exceed 5 times the full load current. Okay, so let me write full load current. Short circuit current does not have to exceed 5 times the full load current. So if I calculate the ratio of short circuit to fault current, full load current, okay, so short circuit current divided by full load current, the ratio of them, how much is it? 1 by 5. 1 by 5 means 0.2, okay, or 20%. Fine. The full load current will be, you have to find out what will be the value of full load current. I have given you one hint. Okay, now I hope that you will be able to solve this as well. Very good, Aryan, you are in great touch of power system. Okay, just keep it up. You have to find out what will be the value of external reactance added. Okay, so external reactance added, you have to find out that, and you have to answer in terms of ohms. Okay, not in per unit. Be very clear about this. This is the common mistakes that anybody can do with fault analysis. Okay, whether we have to answer in ohms or whether we have to answer in per unit. So come on everyone, Aryan, Prakhar, Polly, you can solve these questions. Okay, last one was a bit difficult one, a mixed concept question, and you have given a correct answer for that. So this one will be a bit easier one for you. Okay, so come on guys, you can answer this question. Anybody who is getting the answer? Okay, so just see, when you are adding an external reactance, then something like this is happening. Okay, so when you have added the reactance, this is what is happening here. Okay, now internal resistance is how much? Internal resistance is 5%. Sorry, reactance, not resistance. Internal reactance is 5%. Okay, so added reactance will be, added reactance will be 20% minus 5%, that is 15%. Okay, so from the given condition you can simply find out that when you are adding some reactance, this is what is happening. So 20% is the change happening after the reactance. So how much reactance we have added in series? Already we have 5%, so we have added 15% more. That's why total reactance becomes 20%. So we got the answer that added reactance will be 15% or 0.15 per unit. If suppose we have to answer in per unit, this is done, but we don't have to answer in per unit, we have to answer in ohms. So for that we require the value of X base. Okay, and X base, you know how to calculate, it will be equals to V base upon I base. Now how to find these values? So I base will be S base upon root 3 into V base. How much is S base? 20 MVA upon root 3 into how much is V base? 10 kV. Okay, so from here you will get the value of I base, and that will be 1154.7. Okay, now come back here, X base, which is V base upon I base. Okay, X base will be V base upon I base, and for impedances, current, voltages must be put in phase value. So V base is how much? 10 kV. So 10 into 10 to the power 3 divided by root 3. Okay, divided by I base is 1154.7. So from here you will get the value of X base, which I have calculated to be 5 ohms. Okay, so you will get 5 ohms from here. Now just see, added reactance X added in per unit is this much. So what we can write, X added in ohms divided by X base, this is 0.15 per unit. So how much will be X added? in ohms. This will be 0.15 into base reactance. How much is base? 5. So what you will get? 0.75 ohms. This is how you have to answer this question. You got your answer. Okay. So answer is 0.75 ohms. Just see. Now what they have done, they have just tried to indulge you in the problem statement only, so that you will be stuck there, you will not be able to move ahead. Okay. But if you are conceptually very clear, you will get the answer by reading the question only, isn't it? This is what we have to do in these kind of questions. So be very well prepared for this kind of question as well. I hope this is clear to everyone. Okay. So last 3 questions that we have discussed from fault analysis are very, very important, and surely you are going to get any one of those in the upcoming GATE exam. So let me move ahead for the next question. So this is what we have as a next question. The Z-bus matrix of 2-bus power system is given by this matrix, assuming all pre-fault voltages to be 1 per unit. If a solid 3-phase fault taken place at bus number 1, okay, then the post-fault voltage at bus 2 will be, fault is taking place at bus number 1, what will be the fault voltage at bus number 2 is what you have to calculate, and your time starts now. This is very easy and very, very, very important question. Okay. GATE authorities, they are in true love with these kind of questions. They will definitely give you these kind of question in the exam. Okay. Z-bus matrix is given to you. You have to find post fault voltage at bus 2, and the fault is happening at bus number 1. Very simple analysis. Okay. In these type of questions, very simple analysis is used. Come on guys, this is very easy. I know that you people can manage this question. So last 20 seconds, you have to find the post fault voltage of bus 2. Okay, and fault is happening at bus number 1. So in these kind of questions, first of all, what you have to do, just calculate the fault current. So fault is happening at bus number 1. So use the bus number 1 pre-fault voltage, okay, and bus number 1 impedance, okay, bus number 1 self impedance. So it will be Z11. So what will be the value? Just see, IF fault current, if you will calculate by using V1 upon Z11. So what is V1? We can write it 1 angle 0. And what is Z11? Z11 will be minus J.4. Okay, so how much it will be? When you will solve, you will get the fault current as J2.5. J2.5 per unit as the fault current. Now we have to calculate V2 post fault. So there is a formula related to that. So V2 post fault, this is equals to V1 pre-fault, okay, minus the fault current, and now you have to take the off diagonal element, which is Z12. So what is the pre-fault voltage? 1 angle 0. minus, what is the fault current? J 2.5. What is the value of Z12? It is J 0.1. Okay. Now, when you will solve it further, you will get 1.25 per unit as the answer. Okay, so that's why I was saying it is very, very easy. Okay, so only you should do about this formula. If suppose the fault is happening at bus number 2, you could have used V2 upon Z22. In that case, they should have asked you the bus 1 post fault voltage. So the formula will change. V1 post fault will be, here you will be writing V2, not V1. So V1 post fault will be V1 pre fault minus IF Z12. Okay, so 2 will be replaced with 1. No difference will be there apart from this. This is how you have to approach for these kinds of questions. So be very well prepared. For my personal guess, this is going to be the upcoming gate question. Okay, so this is how we can solve these kind of questions. I hope this is clear to everyone. Very good. So now moving towards the next question. Very fundamental, very conceptual question. A balanced three-phase load consists of delta connected impedances in parallel with solidly grounded star connected impedances as shown below. Which of the following represent the zero sequence network of the above? So delta connected network and star connected network, both are connected together. Now you have to tell us what will be the possible zero sequence impedance network among these four. Okay, and your time starts now. This is very, very fundamental, very conceptual question, I have to say. So what will be the possible zero sequence network of this combination? Delta connected network into star connected network, they are connected together. Possible zero sequence network we have to comment about. Okay, so quickly let me know which is the correct option here. It does not require 2 minutes, but still I have given you 2 minutes. Very conceptual question related to zero sequence network. The ultimate condition is, if you are aware of that, you will be able to solve this question. So guys, we have this delta connected network. Now in this delta connected network, we will be having any zero sequence current. So the zero sequence current will be 0 here, because in delta connected network, no zero sequence current is flowing in the lines. Zero sequence current may flow in the windings, internal windings, but in the lines, there is no zero sequence current. Now for star connected network, zero sequence current can flow if there is neutral grounded present, which is present here. So zero sequence current can flow here, isn't it? Zero sequence currents can flow here. This is non-zero here. Okay. So if there is no zero sequence current in the delta network, whether it will be shown in the equivalent zero sequence network? No. It will be like an open circuit, or if you will not showing it, it is perfectly fine. There is zero sequence current flowing in the star network, so we have to show it, isn't it? So just see here. In this option, they have shown the zero sequence network of delta, which is wrong. In this option, they have only shown the zero sequence network of star, which is correct. This is also wrong. And whether this will be correct, in this only star network is shown, but 3ZF is also there. They have shown this fault impedance as well, isn't it? Whether we will show any fault impedance, we will show fault impedance if fault impedance is present, and it will be 3 times, and then it will be written here, okay, which is not the case here. So this is also wrong. So which is the correct option? Option number B. Fundamental conceptual question, okay, related to zero sequence network concepts. If you are very clear with those, you could have solved this question very easily. Okay, so I hope everybody is getting what we have to do in these kind of scenarios. Okay, now moving towards the next chapter. So this is all about the fault analysis. Some very good, some interesting, some conceptual, fundamentally correct questions we have taken here. Try to practice them as much as you can, because you will get a similar kind of question in the upcoming GATE exam. Now moving towards a very important and a chapter which students find a little tougher. Stability, power system stability. Important topics are stability limit, swing equation, power angle curve, and equal area criteria and its application, specifically the critical clearing angle and critical clearing time. Okay, so let's move towards the first question. So this is what we have as a first question from this chapter. A generator having inertia constant H equals to 6 megajoules per MVA is connected to a synchronous motor having inertia constant of 5 megajoules per MVA. So H of G, this is given 6 megajoules per MVA, and H of M, this is given 5 megajoules per MVA, and they are connected together. Okay, then can you tell me what will be the equivalent H? If two generators are operating in parallel with different H, their equivalent H will be simply the addition of them, isn't it? But if one generator is and one motor is connected together having different inertias constant, then H equivalent will be their parallel combination. Okay, their parallel combination. Now so many students, they will simply add it, and this is where they can mistake in this question. They can be mistaken. Okay, so that is not something that you have to do here. So 6 into 5 upon 6 plus 5, how much is it? 6 into 5 upon 6 plus 5, it is 2.72. Okay, so you will get 2.72 as equivalent H. Now the generator is delivering power of 1 per unit to the motor when a fault occurs which reduces the delivered power. At the time when the reduced power delivered is 0.7 per unit, the angular acceleration of the generator with respect to the motor will be angular acceleration. You have to find d square del by dt square. This is what you have to calculate, and this much hint I have given you is sufficient to solve this question, and your time starts now. We have to answer in electrical degrees per second square. Okay, so by using direct formulas, whatever you will be getting is coming in terms of electrical degree per second square. If suppose they could have asked us about mechanical degree per second square, then we could have used the formula theta electrical equals to p by 2 of theta mechanical, and this is how it would be transformed into electrical to mechanical. Okay, so always be ready about this scenario as well. If they will try to make you confused, they will ask from electrical to mechanical, mechanical to electrical. So whatever way you have to do. Normally the calculation that we are doing is in terms of electrical. Now theta electrical is P by 2 of theta mechanical, you know. So from this you can convert electrical into mechanical if it is required. Okay. But normally whatever calculation you will be doing is coming in electrical degree per second square. So we don't have to do this here in this question. So come on guys, last 10 seconds. Okay, so just see. You know that what is the swing equation? So as per the swing equation, we have d square del by dt square. This is equals to what? Pm minus Pe over m. Okay. Now, RN is getting an answer 990. Very good answer, which is very close to the correct answer. Now, if you see, the generator is delivering power of 1 per unit. So this will be Pm. Now, after fault, the delivered output power, electrical power is 0.7. So 1 minus P is 0.7 upon M. M you can write what? What is the formula of M? H into S upon pi F, isn't it? M is basically H into S upon, and we have to answer in electrical degree. So 180 F. Okay. If we are writing in terms of per unit, then this S will not be there. Okay, you know that. So what we will be writing here is H upon 180 into F. Okay. So what it will be? It will be 0.3 into 180 F upon H equivalent. So 0.3 into 180 into F is the frequency, which is 50, and H is 2.72, isn't it? Now when you will be solving it, you will be getting 992.64 electrical degree per second square. Okay. RN, your and mine answer is very close. So the range will be given and your and my answer will lie in that range. So this is absolutely correct and well done. Okay, fantastic. What they can do here is, they may ask here in terms of electrical radian. So if they have asked for radian, you could have put here 180. Instead of 180, you could have written here pi. Okay. Instead of electrical, they could have asked for mechanical. So if they are asking for mechanical, do not forget to write this. Electrical quantities can be converted into mechanical. Theta mechanical will be what? 2 by P. So you have to multiply the answer with 2 by P and you will be getting an answer into mechanical degree per second square. Okay. So try to just practice these as well. This is what they can modify in the question unless everything will remain same. And remember this as well. Okay. If two alternators are connected in parallel, their equivalent H will be simply added. If motor and generators are connected together, equivalent H will be their parallel combination. If you are aware of these things, you can surely score marks in these kind of question and be very well prepared for these questions. Okay. Now, next question. For the circuit shown in below, so we have a circuit. The steady state power limit is 0.54 per unit with switch S open, 1.27 per unit with switch S closed, 2.24 per unit with switch S open, 1.42 per unit with switch S closed. So this is an MSQ kind of question and you have to calculate a steady state power limit. A steady state power limit means you have to calculate E upon EV upon X. Okay. You have to calculate P max, which is EV upon X, in both the situation when switch is open and when switch is closed. Okay. And your time starts now. this steady state power you have to calculate in both the cases, when the switch is on and when the switch is off. Okay, I think on case is very simple, and in off case you have to think. Come on everyone, you can solve this question. This is very easy. Okay, so just see, with switch S open, okay, so when the switch is open, what will be X equivalent? So when the switch is open, the capacitance will not be in the circuit and we will be having only these elements. So what will be the X equivalent? It will be equals to X of G plus it will be equals to X of T plus X of line plus again X of T1, T2, let me write, and then X of M. Okay, so let me write the impedances of everyone. 1 plus 0.2 plus 0.6 plus 0.2 plus 1. How much we are getting? I think it is 3 per unit, isn't it? It will be equals to 3 per unit. Then what will be the value of P max? P max is EV upon X, steady state power limit. So what is E? 1.2. What is V? 1 upon X equivalent 3. So 1.2 by 3 is around 0.4 per unit. Okay, so 0.44 per unit with switch open. So answer number A is absolutely correct. Okay, now what will happen if the switch is closed? So if suppose we have closed the switch, okay, then what will happen? So when switch is closed, or let me make it here. So when switch is closed, okay, then what do we have? When the switch is closed, we will be having generator reactance, okay, then we will be having the transformer reactance. This is X of G, this is X of T1, okay, generator, transformer. Then we will be having transmission line as well, X of L, okay, and then there is a switch which is now closed, so it will add a capacitance whose impedance is 1 per unit, okay, XC whose impedance is 1 per unit. Now after that we have transformer and motor which is having 0.2 and 1 per unit of reactance. So this is X of T2 and X of M. So guys, what will happen now? So the equivalent circuit, if I draw, it will appear to be like this. We have a generator, okay, and there will be one single reactance of this side, Xg, Xt1 plus XL. So how much will be Xg, Xt1 and XL? 1.2, 0.8. So 1.8. Okay, and then we have a capacitance of 1 per unit reactance. Then at that side, Xt2 plus Xtm. So Xt2 plus Xtm, how much it will be? Xt2 plus Xtm, it will be 1.2. Fine. Now this is E, and we can make a voltage source here as well, which is representing V. Okay. So this is V right now. So we have E, we have V, and can you see this is a star network, isn't it? Now if we convert this star into delta, so convert this star into delta, and you will be getting something like this. So we will be having E, okay, and after conversion it will be like this situation. Okay, so this is our E of F, this is V, and this will be what? Let me call this X12. Okay, so just see. Now, do we need to calculate this value and this value? We don't. Okay, because in order to calculate P max, we will be using E into F into V upon this XV1, isn't it? Because this voltage is EF, this voltage is V. So we only need the value of X12. So don't waste your energy in calculating these values. We only need this reactance. And how we will calculate this reactance? So from here, the X12 value, okay, this value, it will be, just see, J 1.8 plus J 1.2 plus J 1.8 into J 1.2, and this is what? Capacitance. So you will be writing it minus of J, the value of it is 1, okay, minus of J1. So divided by minus of J1, okay. This is what you will do, and you will get the value of X12, okay, which is coming out to be J.84. This is coming out to be J.84. Okay, so when you will do this, X12 that we are getting is equals to J.84. Let me write it here. Now you got everything. EF is 1.2, V is 1 upon 0.84. So when you will do that, what answer you will be getting? You will be getting 1.42. Okay, you will be getting 1.42 per unit of power. So just see, 1.42 means option number D. I hope this is clear to you right now. So when you will close the switch, okay, Xc will become minus of J1. Fine. Now this network is a star connected network. If we will convert this into delta, we will get something like this, on which we don't have to calculate these two, only we are interested in this, which we can find from conversion of star to delta formula like this. You will get the value of X equivalent, put this value, get the answer. Okay. Now I hope that you must have recognized how important this question is for gate point of view, isn't it? They may ask you something like this, isn't it? So practice this question and be very sure what you are going to get in the upcoming gate exam, and this is how you can get a good rank. So moving towards the next question. Now what has been given in this question is a 50 Hz generator connected directly to an infinite bus operating at a voltage of 1 per unit has a synchronous reactance of 1.2 per unit. The generator no load voltage is 1.3 per unit and its inertia constant H is 4 megajoule per MVA. Generator is suddenly loaded to 70% of its maximum power limit. The frequency of the resulting natural oscillations of the generator will be, okay, you have to find out what will be the frequency of natural oscillation. So let me tell you the formula and then you can solve it. So frequency of natural oscillations. Guys, this topic is very much saturated. Okay, so these are the kind of questions that can be asked to you, some unorthodox kind of question. It will be equals to d bar P upon d bar del, add the value of del naught, okay, divided by M. This is what you will calculate. So you will get the value, okay, of frequency of natural oscillation, and it will be coming in radian per second, but you have to answer in hertz. So you will convert that radian per second into hertz. Okay, so this is the formula that you have to use. I think now you will be able to solve it. You need the value of del naught and you need to calculate this differential at del naught. This is the formula that you have to use. Okay, so you require the value of del naught, you require the value of this particular differential at del naught, you require the value of m, just put and calculate the answer. And the hint is given in the question itself. Okay, what you have to do. So last 20 seconds. Come on guys, you can solve this question. It's not a difficult one, only the formula you should know and you will be able to get it through. Last 10 seconds. Okay. So as you know that you require the value of dP upon d del. Okay. Now let me ask you what is PE. So PE is basically EV over X sine of del, or we can write it P max sine of del. Okay. Now just read what is given to us. The generator no load voltage is 1.3. Okay. Bus voltage is 1.2. Inertia constant is given. The generator is suddenly loaded to 70% of its maximum power limit. Okay. So guys, this P equals to P max sine del. Now it is equals to what? 0.7 of P max. Isn't it? And let me call this angle to be del naught. So the generator is suddenly loaded to 70% of its maximum power limit. Okay. So P is basically 0.7 of P max. When you will apply this, you will get the value of del naught. So what will be the value of del naught? Sine inverse 0.7. And after that, you will get 44.42 degree. Okay. Now, we need to calculate the value of Deber P upon dP upon d del at del naught. So when you will differentiate this equation with respect to del naught, what you will be getting? You will be getting EV upon X, sine del will become cos del, and del naught value that you have is 44.42. Now put the values. E value is 1.2, V value is 1, and how much is the equivalent reactance? It is 1.2. Okay, this value is 1.3. Cos of 44.42. When you will solve, this quantity will come out to be 0.7737. Okay, and the unit is very much interesting. What you will be getting is per unit. Just see, P you are calculating in per unit. Del you are putting, so it will be per unit upon radian. Okay, per unit upon radian. Is that clear? Because P we are calculating P by putting all the values in per unit. Okay, so Deber P upon Deber del, it will be in per unit upon radian. Now we require the value of H. So H you know, M, sorry, we require the value of M. So M, as you know, is H into S upon pi into F. Okay, why pi? Because we require in radians. Now as we have to calculate in per unit, so we can simply write upon H upon pi. We can ignore S. How much is H given? H is given 4 megajoule per MVA upon 3.14 into 50. What value of M you will get? When you will solve it, you will get the value of M to be 0.0212. Okay, and this will be in per unit. Now come back here. Come back here and put the values. What answer you will be getting? This value you have calculated is 0.7732. Okay, and the value of M is the value of M is 0.0212. Okay, so come back and write here 0.0212, and then when you will solve it, you will get 60.4 radian per second. Okay, answer will be in radian per second first. Now we have to answer in F. So what will be F? F will be 60.4 radian per second divided by, you know that omega is 2 pi f, so it will be 2 into 3.14, and once you will do that you will get 0.96 hertz. Okay, which is option number B. So just see, if you know the formula you can very easily solve this question. Okay, and this is kind of unorthodox question. Now GATE authorities, they may go for these kind of questions because they have never been the part of the GATE exam. Okay, so be ready for these kind of questions as well. If it is not a difficult one, simple one we have already solved. So if you'll get a question of like that or like this. Okay, so I hope this is clear to everyone. Moving towards the next question. So what do we have in this question? A 50 Hz 3-phase synchronous generator is operating at a steady state load angle of 30 degree while supplying 1 per unit of active power. Steady state angle means del naught is given how much? 30 degree. Okay, how much is power it is supplying? PM is 1 per unit of active power to an infinite bus if the inertia constant H is given 8 megajoule per MVA. A 3-phase solid fault take place which is cleared at a critical clearing angle. Del CR is given 85 degrees. The critical clearing time in second, what will be the value of TCR? This is what we have to calculate here. So for critical clearing time we have a formula which is very popular and you should know about it. Okay, so the critical clearing formula, if you know the formula, very easily you can solve this question. It is 2H del CR minus del naught divided by pi F into PM. Okay, pi into F into PM. So just see, from this given data, if we calculate the value of del CR minus del naught, it will be equals to 85 minus 30. Okay, which is how much? 55 degrees. Okay, in terms of radian, what it will be? 1.91 radians. Why we are calculating in radian? Degrees will be put if suppose something sine and cos are there, but here nothing like that we have, so we have to calculate in radians. Now come back here, 2 into H, H is 8. Okay, del CR minus del naught 1.91, pi 3.14 radian, F is 50, PM is 1. Okay, so we have all the required values. Now when we'll solve, you will get 0.442 second. Okay, just see, if you are aware of the formula, last two problems that we have done, if you are aware of the formula, you can very easily solve that particular question, isn't it? Just see, so this formula that we have is a very important one. Okay, be very well prepared for this formula. And in power system stability chapter, what we have seen is that students, they know about the formula, sometimes they also know about the approach, but there are huge chances that one can be mistaken with mechanical or electrical, degrees or radians. Okay, so be very clear with these concepts and you will be able to solve all the questions. Okay, next question that we have is this one. A machine shown in the figure has an inertia constant of 6 megawatt second per MVA. It is supplying 0.8 per unit active power at 0.8 power factor lagging. Okay, power is 0.8 per unit, power factor is 0.8 per unit. Okay, voltage is 1 per unit. All per unit reactances are marked on the machine rating. So this is the diagram. So the generator reactance, transformer reactance, line reactances are given to us. Okay, the value of critical clearing angle in case of solid 3-phase fault taking place at the generator terminal will be. So guys, we have to calculate the value of del CR here. And what is the formula of del CR if a solid 3-phase fault is taking place? It is cos inverse pi minus 2 del naught cos del naught minus sin del naught. Sorry, sin del naught, okay, minus cos del naught. This is the formula. So now in this formula, what do we have and what do we don't have? So we don't have the value of del naught, and this is the only thing that we require. We don't have the value of del naught. So we have to calculate the value of del naught. Otherwise, there is nothing like which is very tough in this question. Okay, so how we can get the value of del naught? Okay, how we can get the value of del naught? So del naught will be the angle of this generator voltage. Okay, when the fault is happening, at which angle the generator is operating, this is what we have to calculate. So how we can calculate that? So just see, E angle del naught, this is simply equals to V plus I, the current, into J X equivalent. Okay, this is how we can calculate that. So we require the value of I. Now how to calculate the value of I? I will be P over V cos phi. So it is 0.8 upon 1 into 0.8. So we will get what? We will get 1. Okay, and I will be 1. What will be the angle? Minus cos inverse 0.8. So it will be 1 angle minus 36.86 degrees. This is how we will calculate the value of current. Okay, so now the current is with us. So we have the value of current right now with us, and what will be the X equivalent? What will be the X equivalent here? So just see X equivalent. It will be XD, which is J.15, plus it will be transformer reactance, which is J.2, plus it will be the line reactance, which is J.5. So you will get J.85 per unit as X equivalent. Fine. Okay, so now we have this as well. Now we have to just get the value of E from this equation. Okay, so just get the value of E from this equation. How we can get the value of E? So E angle del naught, this is equals to V plus I into J X equivalent. Now V is 1 angle 0, I is 1 angle minus 36.36, okay, and Jx equivalent is J.85. Okay, or otherwise what you can do, 1 plus 0.85, okay, J will give you an angle of 90 minus 36.86 is the angle of current. Okay, this is what you will get. So 1 plus 0.85, so how much we will get? 90 minus 36.86, we will get 0.14, okay, and 90 minus 36, 53.14. Okay, now when you will convert this into rectangular form, or sorry, in polar form, you will be getting 1.65 angle 24.24. Okay, so just see E angle del naught. So what is the value of del naught? 24.24 degrees. This is the value of del naught. Okay, in terms of degrees, in terms of radian, it will be 0.424 radian. Okay, now come back in the formula. So we need the value of del CR, which is cos inverse pi minus 2 del naught sin del naught minus cos del naught. This is the formula, isn't it? Now put the values. So cos inverse pi is 3.14 in radians, minus 2 into del naught in radians is 0.424 sine of 24.24. Okay, where sine and cos are there, we will put the value in terms of degrees, minus cos of 24.24. Okay, so now you require to solve this and you will get the value of 88.34 degrees. Okay, but we have to answer in degrees or radians. The value of critical clearing angle in radians. We have to answer in radians. So in terms of radians, it will be 1.54 radians. Okay, just see. This is how you can solve this question. So this is the very important formula that you should know, and in this we require the value of del naught. So sometimes del naught is given directly and sometimes indirectly we have to calculate from the given data, and this is one such question in which indirectly we have calculated del naught. Okay, so somehow I made you capable of solving these kind of questions as well. Critical clearing angle, critical clearing time, frequency of oscillations, angular acceleration, all these are very, very important questions and topic that you will see in the upcoming GATE exam. Okay, I hope this is clear to everyone. Now let me move towards the last chapter of today, which is relay and circuit breaker. Okay, now what kind of questions we can get from this chapter? Let me just show you. So this is the first question that we have. Okay, now in this question what we have to do? In a 220 kV system, the phase to ground capacitance is 0.01 microfarad and the inductance is 4 Henry. If a magnetizing current of 4 ampere is interrupted, then the voltage appearing across the electrode of circuit breaker will be what? Voltage appearing across the electrode of circuit breaker, we have to calculate. The value of critical resistance to be connected to illuminate restrike will be what? The voltage appearing, and now other values are given. So you have to find out what is the voltage appearing across the breaker contact and what is the value of resistance to be connected. Okay, now we have two very popular formulas related to this, and this is a kind of MSQ question in which they have asked everything about the circuit breakers. Okay, so let me see, are you aware of those required formulas to solve this question? And this is a kind of very good MSQ question. Okay, come on guys, I hope that everybody is aware of the formula required to solve this question. So see, related to V, we have the formula that V is equals to what? I under root L by C. Okay, V is equals to I under root L by C. So I is given 4. What is L and C? 0.0 L is 4. Okay, 4 Henry and 4 Henry, and what is C? 0.01 microfarad. Okay, now when you will solve it, you will get an answer 80 kV. Okay, similarly R is equals to 1 by 2 under root LC. These are the very popular formula, every GATE aspirant know about them. Okay, so they have asked a question related to the same as well, and when you will solve this, you will get 10 kilo ohm as the resistance. So A and D are the correct option. Okay, so all you require to know is these two formulas and you will be able to solve this question. I hope this was very easy one, isn't it? After that, we have one question related to the relays. So the figure shows a percentage differential relay used for the protection of an alternator winding. So this is the percentage differential relay. Okay, this current which we can call I1 and this current which we can call I2, they are given to us, and the CT is having this ratio 500 to 5. The relay has minimum pickup current of 0.2. Okay, so this minimum pickup current will always be there. What current you will be calculating, this must be added in that. This is the default current that we have, and a slope of 14%. Slope, anybody has an idea about slope? Slope in differential relay is basically I1 minus I2 upon I1 plus I2 by 2, and this is given 14%, means 0.14. Okay, if a high ground resistance fault occurs near the grounded neutral and of the generator winding with current distribution as shown in the figure, then the operating current is, what will be the operating current? This is what we have to calculate. Okay, so just see, if I just made the diagram of a differential relay, so that you will get a perfect idea what is happening in this. So this is what? Restraining coil having N by 2 turns, restraining coil having N by 2 turns. Okay, and we have with us the operating coil as well. So this is the operating coil. Okay, now here some current I1 will be coming, and here we will be having some current I2, isn't it? We will be having some current I2 here. And what will be the current in the operating coil? This is the operating coil. Current in the operating coil is I1 minus I2, and this is what you have to calculate. Okay, current in the operating coil. Then the operating current is, so operating current means current in the operating coil is what you have to calculate here. Fine guys. So see, I am calling this to be capital I1 and I am calling this to be capital I2. Can you tell me what will be capital I1 plus capital I2 by 2? This will be 350 plus 310 divided by 2. Okay, how much we will get? We will get 330 amperes. Okay, now this is at the primary side of the CT. What will be the things at the secondary side of the CT? Okay, so at the secondary side of CT, these things will be small. Okay, so now primary things, they will be modified as per the transformation ratio of CT, so which is given 5 to 500. Okay, now when you will do that, I1 plus I2 by 2, it will come 3.3 amperes. Okay, it will come 3.3 amperes. Fine. What we have to calculate is I1 minus I2. Now we have been given the slope. So what is slope? I1 minus I2 upon I1 plus I2 by 2, it is 0.14. So what will be I1 minus I2 here? 0.14 into I1 plus I2 by 2. So 0.14 plus 3.3. How much you will get? 3.44 amperes. Isn't it? 3.44 ampere is what we will get. Is that correct? No. We have to multiply. I have added. This is wrong. Okay. So 0.14 into 3.3. So how much we will be getting? Just multiply this and tell me what will be the value of I1 minus I2. So 3.14 multiplied by, 3.33 multiplied with 0.14, you will get 0.462. Okay. Now 99.9% student will write that this will be the answer, isn't it? And they will ignore simply one fact which is also given here, that there is some default current present as well. Okay, just read the question. Minimum pickup current is 0.2 ampere. This will already be there. This is the default current. So this is the minimum current. So what will be actual current? Okay, so I1 minus I2 actual, it will be whatever you have calculated, you have to add 0.2 as well, and then your answer will be what? 0.66 ampere. This is the correct answer. Okay, now many of the students, they will miss simply this 0.2, and that is where they will just do the mistake. Okay, if it is not given, whatever you have done is correct. This is how you can solve these kind of questions. Be very well prepared. Okay, so I have given you a flavor of differential relay as well. Moving towards the next question, and this is going to be the last question as well. The time of operation of 5 ampere 3 second over current relay having a current setting of 125%. Current setting 125% or 1.25. Relay current is 5 ampere. Okay, so relay secondary current or relay current is 5 ampere. Okay, relay current is 5 ampere and time setting multipliers of 0.6 connected. So time setting multiplier, or we can call it TSM, 0.6. Okay, to supply circuit through a 400/5 current transformer will be, what we have to calculate here, the time of operation is what we have to calculate, and we have been given the PSM curve as well. Okay, so we have been given the PSM curve, and through that we have to calculate what will be the actual time of operation. Okay, so just see, PSM is given, so why don't we calculate PSM? So what is plug setting multiplier? PSM, it is equals to the fault current, okay, divided by the relay primary current. So relay primary current, how we can approach for that? It is equals to the current setting into the CT ratio, okay, into the relay secondary current or relay current. Okay, so when you multiply current setting into CT ratio into the relay current, okay, this is how you will get the primary current as well. So if primary current is given, we can directly write that. So fault current, how much is it? 4000 ampere. Current setting is 1.25. CT ratio will be 400/5. Relay current is 5. Okay, how much we will get? 5 and 5 will get cancelled. We will get 10/1.25. 10/1.25 is how much? It is 8. Okay, so PSM will be 8. And just see, they have given one hint as well. They want to calculate PSM equals to 8. Corresponding to PSM equals to 8, the time of operation is 3.5, isn't it? The time of operation is for a PSM of 8, the time of operation is how much? 3.5 second. Okay, 3.5 second is the time of operation for this PSM, but we have been given the time setting multiplier. So whatever time we are getting on the time setting multiplier, it will be what? So actual time will be as per the TSM rating. Okay, actual time will be 3.5 into 0.6. Okay, so 3.5 into 0.6, it will be 2.1 second. Okay, now most of the students, what they will do, they will simply kick 3.5, which is wrong. 2.1 is correct. 3.5 you are getting as per PSM, but on the time setting multiplier scale, it will get multiplier with the time setting multiplier rating, and this is how you will get the actual current of operation. Sorry, actual time of operation of relay. 2.1 second it will take to operate as per the given conditions. Okay, So we utilize the concept of PSM here. We utilize the concept of TSM here. So this is one such question which is giving you fundamental clarity as well, and it is also very important for the exam point of view. Okay, so be very well prepared for these type of questions. So guys, this is the end of this session today. We discuss almost around in power system. We have taken 2 sessions on GSB on power system. Combined in both the sessions, we have discussed almost 60 plus questions. Just do practice these 60 plus questions and the formulas used in it, and how we are approaching towards that, the kind of confusions we are getting here in these questions. If you will practice these questions very well, it is guaranteed that power system, which is a very important subject, has a weightage around 11 to 13 marks in the exam. You will be able to score maximum marks in the power system. Even almost all marks you will be able to score if you will practice these 60 plus questions. Most of the questions you will get in the exam will somehow involve the same formulas, same tricks, same concepts, and same fundamental things will be there. Okay, if whatever mistakes we are doing here, you will learn from them, and you will not be able to do the same mistake in the upcoming exam. Okay, so this is how this GATE score booster series will benefit you a lot. Not only power system and power electronics, all other subjects are also available in our playlist. You can go and follow that. We have designed some fantastic questions, so that will give you a best practice. Okay.